Minggu depan kelas yang biasalah. Pukul 9. Saya tak ada duty dah. Hari Rabu baru saya duty. Okay dah 18. 18 je. Yang lain dah lunch ke? Dah pergi lunch? Right, chapter 2 pressure. Pressure in liquid 2.1, 2.2 atmospheric pressure, 2.3 gas pressure. Okay, gas pressure ni dia termasuk dalam dia sepatutnya combine dengan atmospheric pressure. Dia lebih kurang sama je. Okay. Aidan Haris. Ada lagi. Edmund. Wait. Kam Tian. Lagi. Okay, semua liquid pressure, atmospheric pressure, gas pressure ni dia related each other. Okay, now we see gas pressure. Gas pressure dia punya definition same with atmospheric pressure. Only gas for the gas here refer to the certain gas that we use lah. Certain gas that we use in the container from the tank. So dia punya definition sama. You just convert the definition for atmospheric pressure is the pressure experienced by the weight applied by the weight of layer of air. So here this one of the gas lah. Weight pressure exerted by the weight of particle of the gas. Particle of gas. You just change the word layer of air and the gas, particle of gas inside a system or container. Shed Mirshad. Oh, Mirshad 5A, Mishraf 5C. Ni twins ke apa? Sibling ke? Shed Mirshad, Shed Mishraf. Adik-beradik ke? Mirshad? Mana tadi ada? Shed Mirshad. You abang ke ataupun twin dengan Mishraf ke? 5C. Saya selalu tertukar you punya nama. Oh, adik-beradik Ya ke ni? Sekejap, mana name list? Mishraf Syed Murtada. Syed Murtada. Sama lah. Kenapa tak masuk je sekali dengan adik you tadi? Siapa yang abang ni? 5E. Mirshad. Mishraf. Patutlah confuse je. Oh. Ada juga twins lain-lain. Ingatkan Wong Carol dengan Wong Carey tu sama kelas, awak lain eh? Okay. Alright, ada lagi yang nak masuk? Nak mula. Okay, yang baru masuk tu. Okay, yang hari ni kita masuk 2.3 gas pressure. Okay, lebih kurang sama dengan atmospheric pressure. Lebih kurang almost the same but not the same. For this gas pressure, we more focus on certain gas that we supply from a tank. Atmospheric pressure is the layer of air surround Earth. That is atmospheric pressure. Gas pressure is certain pressure that we use. Okay, we supply to a system. Okay, this gas pressure we use manometer. Manometer U-tube. Okay, U-tube apparatus. Okay, we already have this in experiment 2.1 in pressure in liquid. Experiment in 2.1, unit 2.1. Hope you can remember that one. Where the the difference in H is D. This H refer to D, and this H also represent the pressure, pressure of the gas. Okay, sama macam 2.1 lah, pressure in liquid. Alright. Okay, the apparatus we call manometer. Okay, manometer. In atmospheric pressure, barometer. Atmospheric pressure, barometer. Gas pressure, manometer. Okay. Manometer also use a different liquid, either water or mercury. I can use either one lah, either water or mercury. Okay, it consists of a glass U-tube containing colored water. A glass U-tube containing colored water or mercury. Okay, so look at the photograph 2.3, example of manometer. Okay, here the blue color is the water, blue colored water. Let's say the scale, we have the same level of high here. So this one represent the atmospheric pressure. Now this one represent the atmospheric pressure. Okay, atmospheric pressure, same level. Okay. Now, from the photograph 2.3, okay, we convert to a diagram. Okay, diagram A, before connecting to a gas supply, the level of water are same. So here is the acting of atmospheric pressure. This water experience atmospheric pressure. The level same. Okay. Now, B, in diagram B, we connect this U-tube with to a gas supply. Okay, gas X. So this gas X connected manometer with the gas X. Okay, with the silicon tube here. And then we supply the gas enter the U-tube. Now there are differences in height. Difference in height of the color water. Okay. Now here at point A, this point A refer to the gas pressure. This point A represent the gas pressure. Pressure at A, pressure at point A equal to the gas pressure that we supply. Okay. And B, pressure at point B. Okay, pressure at point B here equal to the high, equal to the pressure, atmospheric pressure and pressure due to difference in high. Okay, so for pressure in B equal to H plus P ATM, atmospheric pressure. But however, pressure at A equal to pressure at B, because at the same height. Okay, I draw another line here. Okay, this capital letter H. Point A and point B have same height, same level, same point, same level of water at this point. So pressure A, pressure at A equal to pressure at B. This one. Pressure at A equal to pressure at B. So we can find the pressure of the gas supply. Okay. Boleh ya? Pressure at A equal to gas pressure. Pressure at A, at point A equal to the gas pressure that we supply. Pressure at B equal to pressure due to difference in high and also atmospheric pressure. So we know that point A and point B at the same level. Then we can find the pressure of the gas equal to high plus atmospheric pressure. Boleh? We use this equation to find the pressure of the gas. To find the pressure of the gas, as we know that uh, pressure at A equal to pressure at B. So pressure of gas equal to H plus atmospheric pressure. Okay, pressure of the gas equal to H plus atmospheric pressure. Tambah sahaja. Ada soalan? Okay, the unit used is cm H2O. A meter water or cm water, cm H2O or meter H2O. Based on the apparatus we use, or depends on the unit that we use. Okay. Atmospheric pressure also the unit in meter H2O or cm H2O. We must use the same unit for calculation. Must use the same unit. If high is measured in cm H2O, so atmospheric pressure also must use cm H2O. Same unit. Okay. Why cm H2O? Why we use H2O? Why not mercury? Because we use water here. We use water. The solution is water. If the question state it use manometer mercury, so we must use meter, centimeter or meter mercury. Okay, depends on the apparatus use also. Okay. The high H of the water column represent the difference between the gas pressure and the atmospheric pressure. Okay. The H here represent the difference between the gas pressure and atmospheric pressure. Ana? Boleh tak? If we remove the gas, the water will return to their original position, which is atmospheric pressure. So dia akan balik semula macam ni, atmospheric pressure. Still remember the value for atmospheric pressure? Boleh ingat lagi tak? Ada berapa unit untuk pressure? Logan bermasuk. Okay. Um, tengok balik. Unit for pressure, we have four type of unit. Atmospheric pressure, we have meter mercury. Okay, we use mercury barometer. Still remember the barometer? We have three type of barometer also. Mercury barometer, 1 meter, pelik lah pula gambar ni. Okay, 1 meter glass tube, 1 meter long glass tube inverted in a bowl of mercury. This is barometer. We also have aneroid, and one more is 14. Which one is more flexible? Aneroid. Aneroid is more portable, more flexible, can be used at home, can give direct reading, and also small in size. Okay. 14 dia punya advantage more accurate, but it's not portable, and it takes long time to take reading. Okay. Barometer. We used to measure the atmospheric pressure using mercury. Okay, this one to measure atmospheric pressure, not gas pressure. Okay, second unit is in Pascal. Because this one we use P equal to rho GH. Okay, P equal to rho GH. Okay, for Pascal. And then we have meter H2O, length, difference in height or depth or length by using water. Okay, and then we have millibar. Okay. Look at the first one. Okay, ulang balik. Bagi you ingat. Right, for number 1, meter mercury. By using the mercury barometer, we will get the value for atmospheric pressure. Okay, 0.6 meter in meter. We also have in centimeter 76. In millimeter, we have 660. So be careful with the prefix use. Meter, centimeter, millimeter. Okay. If the question asks you to convert from meter mercury or from millimeter mercury to Pascal, okay, this one lah, these two, convert to Pascal. So make sure you convert cm to meter first. Convert 76 cm to meter, 0.76, and then you substitute into the rho hg. Okay. Number 2, Pascal. Okay. Pascal, you already know Pascal, rho GH, rho is the density for mercury lah. If we use mercury, so the density must be for the mercury. Chin Kit Yen. Okay. And then gravity, gravitational acceleration, and height. Height of the mercury barometer, 0.76 meter. Must be in meter. To convert to Pascal, must be in meter. SI unit for length, meter. So we get the fixed value of atmospheric pressure, 101,396 Pascal. Okay, or 1013 kilo Pascal. Okay, the third one is in meter H2O. Okay, this one meter H2O measure the pressure from what atmosphere equal to 10 meter H2O deeper into the water. So this also got their fixed unit. For atmospheric pressure using meter H2O is 10.3 meter H2O for atmospheric pressure. Got certain value also. Okay, number 4, from millibar to from Pascal to millibar. We want to convert from Pascal to millibar. So if there any question ask you to convert from Pascal to millibar, so remember 1 millibar equal to 1 hectopascal. Hecto is 100. Hecto is 100. Kilo is 1000. So 1 millibar equal to 100 Pascal. From this value, 101396 Pascal, you convert into millibar, you just divide by 100. Just divide by 100. Okay, divide 100 to get the value in millibar. Bahagi 100. Then we get 1013 millibar. Okay. Kan? There's 4 different unit for pressure. Okay. Ada nak tanya lagi yang unit ni? Oh, depends on height. Depends on the depth. This one got meter. Depth also. This one also got high depth. This one also depth meter. Millibar ni tak ada meter lah. Okay, ini dia punya conversion of the unit. Okay. Stop this one. Go back to the notes. Okay. Right now, this manometer to measure gas pressure. We use manometer to measure gas pressure, not barometer. Okay, not a barometer. Okay, to find the pressure of the gas, okay, we use manometer, colored water. This water also can be replaced by mercury. Okay, but mercury is too dangerous lah. Takkan nak guna mercury dalam lab kot. Tak boleh Okay, this one can understand for this one. How to find the pressure of the gas? We just add. Just add the depth or the height of the water column with the atmospheric pressure. This means that here the gas pressure is higher than atmospheric pressure. The gas pressure is higher than atmospheric pressure. That's why we need to add with the high. With the high. It gives higher pressure to the colored water until the water column rise. Until the water column rise. So this gas pressure higher than atmospheric pressure. How much higher? How much higher is the high? Depends on the high. Depends on the high of the water color. So we must add with atmospheric pressure. Okay. Activity 2.5. Okay, this one. Use water manometer. Water manometer, red color. Okay. This one, this activity want to determine the pressure of gas inside the syringe. Inside this syringe, plastic syringe here. They supply gas. This gas means the air inside the syringe lah. The air inside the syringe. We want to know the pressure of this air. Okay. We push the piston of the syringe so that the air flow into the rubber tube and enter the manometer, water manometer. Then it will give rise to the color water. So here is the H. So this H is the responding variable. This H is responding variable. And then the change in volume inside the syringe is considered as manipulated variable. We change the volume of the gas when we press the piston. Volume, we use volume inside the syringe, right? Okay, to find the pressure of the gas inside the syringe, we use the equation. Okay, pressure of the gas equal to height, rise of the water color here, plus atmospheric pressure. Okay. Wait for a minute.
Apa makannya apa tu?
Ya. Tunggu kejap Azana. Ambil sendiri lah. Yang
Nak makan.
gimana? You vanish. Oh, you ni tengah hari baru ada lah. Okay, tunggu azan. Sembilan, 27. 27.
Kering. Asyik roti. Yang dimakan.
Randy tak ada. Darshwin. 27. Ada yang tak ada nama kat sini. Okay. Okay, sambung balik. Alright, to determine the gas pressure inside the syringe. Okay, we need to determine the height between the water levels in both arms of the U-tube. Okay, repeat step 2 and 3. Okay. Okay. Oh, okay. Alright, dia punya instruction. Okay, set up dulu. Okay, tengok ke atas. Make sure that the volume of air in the syringe is 10 ml. So, dia punya manipulated variable, dia fix dulu 10 ml. First 10 ml. And the water levels in both arms are the same. Yeah? Before the experiment, before we push the piston, we need to make sure that the volume inside the syringe is 10 ml. And then the level of the U-tube are the same. Means that the atmospheric pressure same, same level. Okay. After that, we push the piston into 8 millimeter. Okay, the volume become 8 millimeter, and we determine the height. Measure the height in meter, and after that we measure the air pressure inside the syringe. This is the final reading. This one for calculation. This one after the calculation. Ania, Ania, dekat luar. Okay, and then, alright, padam jap. Okay. Okay, we start with 10 ml, and then we push the piston until 8 millimeter. The volume inside the syringe is 8 millimeter. Then we measure the height. Okay. Let's say the first one we get okay 10 meter. Banyak sangat 10 meter. Okay, 2 meter lah. Okay, 2 meter. And then we calculate the air pressure. So this air pressure we need to use the equation. The equation, gas pressure equal to H. Okay, H that we measure plus with the atmospheric pressure. The atmospheric pressure given in the procedure here, use the value atmospheric pressure equal to 10 meter H2O. So we need to add with 10 meter H2O. Okay, this one stand for atmospheric pressure. Okay, 10 meter H2O. We use H2O, right? Water manometer. So the value for atmospheric pressure is fixed to 10 meter H2O. Okay, now for this one, the first one, the air pressure here become 12 meter H2O. Now for the next volume of the syringe, we push again until left 6 milliliter, 6 ml. So what happened to the high? What happened to the high of the water column? What happened? Is it increase or decrease? Increase or decrease? Hmm. Anyone to answer? If we reduce the volume, reduce the volume to 6. Okay, one and wrong. Increase in height. Are you sure? Why increase in height? Why? Why increase in height? Water decrease. Edmund Ng said water decrease. Water decrease in high. Decrease pula. Decrease in high. You see the high here. If you push this piston to the right. So what happened to the high here? To the high. Difference in high. Is it increase or decrease? Yes, and wrong. It will increase in high. After you push and push and push, the color of water become rise and rise. Rise and rise. So the difference in height also increase. A difference in height also increase. Okay, because the gas pressure, because of the pressure. Still, remember this one. Okay, saya bagi example. One big container with a small container that contain a same. This one got same volume, but different size. So which one is the higher pressure, A or B? Two container with same gas particle, same volume of gas particle. Tapi dia punya size container tu kecil. So yang mana dia punya gas pressure high? A or B? Which one? A or B? A or B? Which one give higher pressure? B or, B or A pula. So if we look at the equation P equal to F over A. Yes, B. B will have a higher pressure. Okay. We have higher pressure because the container is small. The particle move in high speed at all direction, and this one dia punya force become less. Okay, so B has higher pressure. So relate with the volume. Okay, relate with the volume. First one at 10 ml and we push to 8 ml. Okay, it give a high 2 meter H2O. Then you push again for the second round until 6 ml. Then the high will increase to 4. Example. And then for the third one, you push again to 4 ml. So there's also increase in high to 6 meter H2O. So if the volume decrease, the high will increase. High will decrease. Okay. This one dah masuk gas law. Gas law PV over T. PV over T. So this one is PV, Boyle's law. Ini dia dah combine sekali dengan heat lah. Okay. We skip that one. Okay, tengok yang ini. So this one, kalau dia nak graph. So the graph will be inversely proportional. The graph will be inversely proportional. Okay, air pressure and then volume. Wait, volume here, and then this one is height or pressure. Inversely proportional. Okay, boleh ya? Volume decrease, pressure increase. Volume decrease, pressure will increase. Okay, example 1, solving problem in daily life involving gas pressure. Figure 2.19 shows a mercury manometer connected to a flask with compressed gas. You are given some information. Atmospheric pressure 76 centimeter mercury. So means here it use mercury manometer. Hmm. Hmm. Okay, the density of mercury and gravitational acceleration. The question is A. What is the pressure of the compressed gas in centimeter mercury? Okay. What is the pressure of the compressed gas? So the pressure of the gas here, use the formula given. The pressure of the gas equal to difference in height plus atmospheric pressure. Okay, you already given in the diagram 40 cm. 40 cm. So just add. Make sure unit sama. Make sure use the same unit, either atmospheric pressure centimeter. The height also in centimeter. So just add 40 plus 76. Okay. Then we get the we can get the gas pressure P equal to 116 cm mercury. Okay, second question. Calculate the gas pressure in Pascal. Okay, from cm mercury, from centimeter mercury, you need to convert to Pascal. Okay, how to convert to Pascal? Use the equation P equal to rho GH. Okay, ingat dah. Nak convert kepada Pascal, use P equal to rho GH. So density of mercury, gravity and height. Height from what you got in question A. 116 cm, you must convert to meter. Okay, for Pascal must be in meter. The height must be in meter. So convert dulu kepada meter. Any question if want you to convert to Pascal, make sure must convert to meter. Convert to meter. Because Pascal is the SI unit for pressure and SI unit for length or height is meter. Meter. Okay. Then you got the answer. Okay, this is in standard form lah. In standard form. Times 10 power of blah blah. Power of n. So this one in standard form. If you want to use prefix, you can use 155,000. 1, 2, 3, 4, 5 times. Okay, Pascal. This is the original answer. 155,000 Pascal. So if you want to use prefix, okay, nak guna prefix boleh. So we can use kilopascal. So it become 155 kilopascal. Divide by 1000. Okay, this one by using prefix. This one is standard form. Standard form. Okay. Question C. Will your answer in A and B change if the glass tube of the manometer has a larger diameter? Okay, is it the pressure The value of pressure, is it affected by the diameter? Okay, the answer is no. Because the pressure in liquid does not depend on the surface area. Not depends on surface area. Pressure in liquid. Pressure in liquid. P equal to rho G H. And atmospheric pressure. Pressure in liquid. Okay. Can ah? Boleh tak ni? Ada soalan? Kalau tak faham, tanya. Okay, next. Example 2. Figure 2.20 shows a mercury manometer. Okay, mercury manometer used to measure the pressure in an airflow pipe. What is the difference? What is the difference between the air pressure in the pipe and the atmospheric pressure in cm mercury? In cm mercury. What's the difference? We have here the difference in height is 25 cm. So the answer is 25 cm mercury. Just take the length. Just take the length. The difference. The difference in the height. Okay. So the answer is 25 cm mercury. Because it already used the mercury here. Already used mercury inside the manometer. So 25 cm mercury. Okay. If the atmospheric pressure in is 75 cm mercury. Okay, now in this question it is 75 cm mercury. Yang saya explain 76. 76 cm mercury or 760 mm mercury or 0.76 meter mercury. Now it use 75. So only got this either these two values lah, 75 or 76. Cannot be 74 or cannot be 77. Yang ni tak pernah lagi, tak ada lagi dalam soalan. Yang ada 75 or 76. Okay. If the atmospheric pressure is 75 cm mercury, what is the pressure in the pipe in Pascal? Okay. So, tengok je Pascal, we must use P equal to rho GH. Convert. Terus convert using this equation. Okay. Okay, wait. Before you convert to Pascal, you need to measure the air pressure first. We don't know the air pressure, the actual air pressure. Okay. Find the air pressure first. Find the air pressure that exert the mercury here. Find the air pressure. This air pressure here. So find air pressure. We add first 25 cm plus 75 cm mercury. Then we have here 100 cm mercury. 100 cm mercury is the air pressure. Okay. After that, you convert into Pascal. Convert into Pascal. Make sure cm. 100 cm convert to meter. 100 cm convert to meter. Okay. So use 100 times 10 power of negative 2 meter. Centi. 10 power of negative 2 here stand for centi. Centi. 10 negative 2. Okay. Times density of mercury and gravity. And then we got the answer. 1.33 times 10 power of 5 Pascal. Okay. Biasa you akan, kalau you nak terus tukar, we can get 1 meter lah. 100 cm equal to 1 meter. So 1 meter times 30,600 times gravity. Okay, yang ni dia right step by step. Yang ni dia tukar senti kepada meter, dia tulis satu-satu detail. So kalau if here we have 100 millimeter mercury, convert to meter. So 100 times 10 power of negative 3. Milli is negative 3. Okay. Yeah. You change the value of the prefix. Okay. Boleh ya? Okay, then for 2.3. Habis. Right, yang ni boleh kira tak? Number 1. Shows a water manometer connected to a flask containing gas. Compare the gas pressure in the flask with the atmospheric pressure. Compare. Make a comparison between the gas pressure and atmospheric pressure. So kalau compare, okay, the word compare, which one is highest lah? Which one is highest? Which one is lowest? Which one bigger? Which one smaller? So it means here, the gas pressure is higher than atmospheric pressure. The gas inside the flask push the water. Push water. Means that the gas pressure here higher than atmospheric pressure outside. Okay. Right, then state the difference between. So difference between the gas pressure and atmospheric pressure is refer to high. Difference between refer to high. What difference in high? In meter H2O. In meter H2O. So kita dah tahu this one use water. So difference in high in meter. In the diagram state 36 cm. So you must convert to meter. Berapa? Convert to meter? Kacang goreng ni. 36 cm to meter is 0.36. 0.36 meter. Right. Okay. Okay, so in meter H2O is 0.36 meter H2O. Masukkan saja dalam unit. Dia punya length ni masukkan saja dalam unit. Make sure unit tu sama yang sama dengan soalan meter. Bukan terus masuk 36 meter H2O. Without looking at the unit use. Right. Okay. C. Calculate the gas pressure in Pascal. Calculate the gas pressure in Pascal. Okay. First you need to determine the gas pressure first. What is the gas pressure? So the gas pressure is high plus atmospheric pressure. Okay. So what's the high? We can use meter H2O first. We can use meter H2O. So high is 0.36. 0.36 meter H2O plus atmospheric pressure given in the question is 10.3. This one, atmospheric pressure 10.3 meter H2O. So plus 10.3 meter H2O. Then we got we got 10.66 meter H2O. Right. 10.66 meter H2O. Okay, boleh? Boleh yang ni? Okay, now convert to Pascal. Convert to Pascal. Just use the same equation. P equal to rho GH. Okay, P equal to rho GH. Now we already know the density of water 1000 kilogram. Okay, gravity 9.81. And then high. Where can we get the high? Where we can get the high? What is the high? So the high here, just take from the answer from the gas pressure. that you have calculated the gas pressure after we add. Okay, 10.66 meter. 10.66 meter. Then find the value in Pascal. Find the value in Pascal. Use the same length here, 10.66 meter. Okay. Boleh tak ni? Okay. Number 2. What are the advantages of using a mercury manometer rather to water manometer? Why? Any answer? Any idea? Why we use mercury in thermometer? Same concept. Same concept for thermometer. Why we use mercury? Why we not use water? Okay, it's very sensitive to. Kalau thermometer, we can say that it's very sensitive to heat. For this one, is it gas pressure related with heat? Okay, the second point, mercury can expand lah. Means that it can give the accurate reading. Not sensitive to heat, sensitive to the pressure or change. Sensitive to the change. Sensitive to the pressure lah, because we relate with the pressure. Okay. For thermometer, we can relate to heat. Sensitive to heat. So this one, mercury, sensitive to change of pressure. And it also does not stick to the wall. Does not stick to the wall of the manometer. Okay. Number 3. We have two different reading of compressed gas and atmospheric pressure. With 180 kilopascal and 101 kilopascal respectively. So it means here 180 is for compressed gas, 101 is for atmospheric pressure. Okay, calculate the difference in height between the two mercury columns in the manometer. Find H. Calculate the difference in H. So how to solve this? Okay. Siapa boleh kira? Number 3. Macam mana dia punya first step dulu? Apa nak cari? Kita nak tahu H. So H tu nak guna equation apa? This one already state in Pascal. So equation is rho GH lah. Rho GH. So find H. How to find H? You just compare. Compare je lah. Find difference. Find the difference means you minus 180 minus 101 kilopascal. You get the answer. For the difference, get the answer in kilopascal, and then you find the H by using rho GH. Find the H. So the pressure that you got divide by rho G. Okay, baru dapat H. Itu sahaja. Ada soalan? Time's up ah. Bukan 2.5 ke? Ya ke, Kuan Siong? Okay. We done here. So, yang latihan tu saya tak tengok lagi. Okay, we continue Monday. Alright. Stop here. Okay. Can dismiss now lah. Tengah hari dah ni. Okay. Cepat semua, lagi mana ni?